I don't know about you, but the notion of time is really intriguing to me. It's a purely artificial notion. I mean, we humans invented it. And as an experiment, I asked my cat what time it was one day, and needless to say, it wasn't very conclusive. And yet, the notion of time is so central to our lives. Our work, our leisures, our projects depend on it. So much so that time series predictions represent a big part of the statistics and machine learning world. And to talk about all that, who better than a time master, namely Sean Taylor. Sean is a co-creator of the Prophet time series package, available in R and Python. He's a social scientist and statistician, specialized in methods for solving causal inference and business decision problems. Sean is particularly interested in building tools for practitioners working on real-world problems and likes to hang out with people from many fields. Computer scientists, economists, political scientists, statisticians, machine learning researchers, business school scholars. Although, I guess he does that remotely these days. Currently head of the rideshare labs team at Teelift, Sean was a research scientist and manager on Facebook's core data science team and did a PhD in information systems at NYU's Stern School of Business. He did his undergraduate at the University of Pennsylvania, studying economics, finance, and information systems. Last but not least, he grew up in Philadelphia, so, of course, he is a huge Eagles fan. For my non-US listeners, we're talking about the football team here, not the bird. We also talked about two of my favorite topics, science communication and epistemology, so I had a lot of fun talking with Sean, and I hope you'll deem this episode a good investment of your time. This is Learning Bayesian Statistics, episode 37, recorded December 3rd, 2020. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach a true Bayesian state of mind by visiting learnbayesstats.com. That's learnbayesstats.com. Do you want to support the podcast and unlock exclusive Bayesian swag at the same time? Then you can visit my Patreon page at patreon.com/learnbayesstats. Starting at €3, you can get various benefits like the private LBS Slack channel, early access to special episodes, selecting questions for episodes, or even coming on the show. You'll get more details at patreon.com/learnbayesstats. Thanks a lot, folks. I'm very grateful for any support you can bring me.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen, maybe cause my likeness lowers expectations of tight rhyming. How would I know unless I'm rhyming in front of a bunch of blind men, dropping placebo-controlled science like I'm Richard Feynman?
Hello, my favorite Bayesians. I'm proud to say that this episode of the Learning Bayesian Statistics podcast is brought to you by Teelift. Teelift is making open source work better for everyone, users, companies, and core developers. Make sure to listen to their dedicated segment during the show to discover how they help open source software. And by the way, if your company wants to support this podcast, raise its brand awareness, or put its job ads in front of the right people, just get in touch with me and we'll see what we can do together. Before listening to Sean, I wanted to give you a quick personal update and a testimony that open source development truly is life-changing. 4 years ago, I did not know how to code. And today, with a few people who, to me, were first GitHub handles, then fellow Pymc core developers, then friends, I'm co-founding a Bayesian data science consultancy called Pymc Labs. So, if you need us to solve unique and difficult problems with major consequences for your company, do get in touch or visit pymc-labs.io. We'll be happy to help. Okay, now let's take the time to talk about time with Sean Taylor. This topic lends itself very well to bad puns. Sean Taylor, welcome to Learning Bayesian Statistics. Thanks a lot for taking the time. I'm super happy to have you on the show. I don't know if Prophet somehow had forecasted that you would come on the show. I hope so. No, but yeah, kidding aside, I'm super happy to have you there because Prophet is actually one of the first packages I encountered when I started doing Bayesian stuff. So super happy to talk about all that with you and about a lot more topics actually that we have for our listeners. But first, as usual, let's start by your background because you started with social science actually and economics in particular. So how come and what's your story basically?
Yeah, there's sort of a winding road, but I think that data science interleaved with everything. When I was an undergrad, I did real estate research with a professor, and I thought, wow, it's amazing that people can have this job where they get paid to just like study interesting questions. And the idea of doing academic research became really appealing at that point.
Mm-hmm.
And I ended up working at the Federal Reserve Board in Washington, D.C., doing economic research because I wanted to learn from more researchers and also take some additional classes before I applied to graduate school for economics. And then along the way to doing that, I think I realized that I didn't love economics as much as my peers there did. So I had these friends who were going off to do PhDs in economics. So I decided to do a little bit of a hybrid thing and get a PhD from a business school. And my field that I studied was called information systems. It's an interdisciplinary field. So I got to study sort of a mix of economics and sociology on the social science side, but then also statistics and machine learning.
Mm-hmm.
And so it was great to get the breadth of experience there. And the research that I focused on in graduate school was on what people call pure effects. So the effect of one person's behavior on another person's behavior.
Okay.
Those questions are really devilishly hard statistical questions. They're very easy to state, but very difficult to study. So a lot of my work ended up sort of being very data focused. And that was back in like 2010 or so. I was starting to work on those kinds of topics. And it was big data and web scale became very hot topics and became very clear that to study those kinds of things, I was going to need to go partner with an industry company and try to like actually get some real data. So I got very lucky and got an internship at Facebook, and it unlocked a whole new world of being able to analyze things at a very large scale. And actually, like the big thing there was being able to conduct randomized experiments. So the work at Facebook was great because I got to work on just like a number of different problems. And I think my career has evolved since then. So the actual questions about social science have sort of faded into the background. And now I feel like I'm more of a methodologist. Like I like to sort of try to figure out how to answer questions for other people rather than come up with the questions myself. Mm-hmm. So a little bit of deferring the hard part to other people and working on the part that I think is a little bit more interesting sometimes.
Mm-hmm.
But yeah, so it's a little bit of a winding road, but I think that the theme all along has been empiricism. I think I'm very interested in like how we can learn from the world and use data that we collect in order to gain new insights and make better decisions.
Yeah, this definitely sounds like a topic that has been present all along your career, up until now at least. Just picking up questions and trying to answer them with the best possible way. And also like you have this emphasis about causal inference and so on that I guess you picked up for your economics background, but we'll come back to that later. And you did a bit answer this question already, but you did say how you ended up in the stats and data science world in the end. And like serendipity seems to have had a lot to do with that. Also, I'm wondering, when did you realize that you were actually more interested in the methodological side of things, as you were saying, instead of more on the applied side of things?
I don't know if it was a realization with any particular project, but realizing that I could get interested in almost any project. Mm-hmm. I think working at a company like Facebook is a great place to explore many different topics. So there were forecasting problems, there were product questions, there were, even like questions related to infrastructure and how we would efficiently manage, machines that we were operating as servers. And there's just like this wide breadth of questions that people were asking. And I think what I started to realize is that the interesting patterns were what was similar about the problems rather than any particular problem on its own. And so starting to cluster the questions that were incoming into like categories of questions became the way that I would think about things, rather than the specific questions themselves were just like special cases of types of problems in the world. And so I think that step from specific thing into a general class of problems is a really fun and interesting one. I think that you can only really get there with being exposed to like a breadth of problems. So leaving my field as an academic discipline and throwing out the phenomenological aspects of it and just say like, well, what is common about how the people in the infrastructure team think and what is common about the people on the product teams, and trying to kind of relate all those things together became the more interesting thing. So I still think of it as a social science problem in a way, which is like people have questions. And there's this like kind of social science of like, how do you map their questions into like an approach and a set of methods for helping them either make decisions or answer those questions?
Yeah. Okay. Makes sense. I think I had like kind of the same path in some sense, coming from the political science side of things, not from the economics, but really getting more and more interested into the weeds and the statistical methods underlying all these questions that I had. And like even more than the answer to the question, the way that you can answer the question and how reliably you can answer them is really important actually to know about, and something that I find at least fascinating.
Oh yeah, it's a whole new set of sensory apparatus that we're developing as humans. We can kind of now take these distributed measurements throughout the world and compile them into data sets. And then so if you had a new sensor, like somebody gave you a new kind of eye on your head or something like that, you would need to sort of figure out how to make sense of the information that's coming in from it. And that's what we're doing right now. We're evolving as humans to sort of like figure out how to make sense of all this new data input that we've created. And that's a really fun and exciting challenge. It's like, how do we structure this thing that we haven't evolved any apparatus for dealing with, that we have to create it on our own. It's an artifact. That's super exciting. And what we can know now is like expanded into many orders of magnitude because of this new sensory apparatus, but we're still learning how to make any sense of it.
Yeah, and since you're talking about this data science stuff, I'm wondering where you're at on your reflections about what data science really is, because I know it's something you often think about.
I have worked on a lot of different kinds of problems at this point, and I think the diversity of it is actually like one of the interesting aspects of it, is that I think sometimes I think of data science as playing like a matching role, as trying to match problems to solutions. And so you have to be flexible and you have to be a generalist in order to be successful at it. Because if you sort of like only interested in a specific class of questions or only interested in a specific class of methods, then you're very limited in what you're able to do. But if you can kind of be a generalist and think about how to cluster problems and cluster solutions and then figure out how to match them, then you can create a lot of value that way. I think of a lot of the role of data science as like match value between how to approach problems and what solutions are available, what problems are available, how can we match them efficiently. And all those questions are empirical ones. So they're sort of like questions about the world where like, if we knew the answer to this question, that we could make a better decision and that would help people. So if I were to kind of like reflect on data science as a discipline, it's purely like empiricism in a lot of ways. It's just like, I need to kind of like take measurements about the world and then use that information in order to do something better than what I was doing before. It's a very general statement, but I think it's actually specific enough to define a field in a lot of ways.
Yeah. I see what you mean. Definitely the diversity aspect of it is both what makes it very interesting, as you said, but also very hard to define. And I guess I'm less and less trying to find a definition for data science as a whole. This is so diverse that I'm not sure you can really pin it down to something really unique in one word.
No, and it kind of has to evolve over time. So it's just as science has. I think the way that we think about science isn't really static. I think the conception of science changes over time as questions change and as our tools that are available for answering them change. And I think data science is just sort of a very similar idea. Just, maybe how to separate data science from science is a little bit harder, which is like, well, what's different about learning about the world and learning about the world in order to make better decisions or do something more effectively? There's a little bit of like technology versus science. But it's really at the end of the day, like you have to be, one of the common themes of all the things I just talked about, or communication is really important, because you're sort of like communicating with people who have domain knowledge about problems or know what's interesting. I think that like in order to perform this matching function that I'm talking about, you need to be able to communicate with the people who can provide solutions and methodologies, knowing about all the state-of-the-art methods that are being created and what's possible. And then also knowing about what's interesting for people to know within a business or within a scientific field and trying to communicate with them. So one of the big themes seems to be information processing from many diverse sources of problems and solutions.
Yeah, I love these epistemological discussions. Super interesting. I think it's also super timely because like in France, for instance, and I'm sure it has been the same in the US, at least in some states or else, but there has been really these discussions and even sometimes heated debates about science and the role of science, especially in the pandemic right now that we're all living through. And interestingly, many people who didn't really know actually about science, were really surprised actually that researchers and epidemiologists and so on didn't really agree, at least in the beginning, on what to do and really on what COVID could do to your body, or just what seems like simple facts like that. Well, we didn't know that at the beginning because it was a really brand new disease. And so you had many epidemiologists and medical experts going on television shows and radio shows and arguing about that. While usually you don't have that. You don't have really like epidemiologists going on TV to debate the really latest advances in epidemiological science. You got to see the sausage making, basically. And so the result was that a lot of people ended up confounding science and research. There is this great philosopher and epistemological thinker in France right now who is also a theoretical physicist who's called Etienne Klein. And he's actually got a really nice definition, I find, of science and research. And he's usually saying that we shouldn't mix one for the other, and that science is actually a basis of knowledge that we know and accumulated for years, but that research is actually science in the making. And so it's not because that we didn't know at the beginning of the pandemic that, okay, you have to wear a mask to get protected from COVID and so on, that all the things we learned before through science, which is that vaccine work, which is that the earth is not flat, which is stuff like that. Well, just because research is still looking for some answers on one topic doesn't mean that you have to get rid of all the knowledge that you got by science before all that.
Yeah, I like that a lot. I think if there's one bright side to COVID, it's that it's really taught us a lot about how we would deal with a new phenomenon and come to process it as a collective body of people and thinking about things. And I think that there's a nice analogy to Bayesian statistics here, which is sort of, there's the prior and the data and the posterior. Relying on experts when they have good priors, then the data is not as useful. The priors have been based on a lot of information that we've gathered for a long time. In a brand new phenomenon, the priors should be weak and the data should speak a lot more. The active research is like going from prior to posterior. And so we're doing that in a very distributed way without like a holistic model that we all share. And so I think that there's a lot of obvious problems in how we do that right now that I think are going to hopefully get better over time. But just seeing that posterior updating happening in real time across all of society has been very fascinating to watch.
Oh, yeah. Yeah, definitely. I think the other side of this coin is that when your priors are weak and you rely mostly on data, then first you have to be prepared to overfit most often, at least at the beginning. And second, you have to be prepared to update your posteriors pretty often, And something that was really interesting to me at the beginning, like in March or April in France, was like people had a really hard time to see these posteriors and priors, being updated like almost day to day with new data coming in, And it's like, wait, you can have it both ways. You can have weak priors and then complaining because then you have to update your knowledge all the time. One goes with the other. So it was also super interesting to see people coping with so much uncertainties and then having a really hard time understanding that when there is a lot of uncertainty and weak priors, then you need to update very often what you think about the state of the world.
Yes. Yeah, it's truly been fascinating to watch. And I think also just that we don't all agree. It very much highlights that we don't all agree on our priors. And so you can end up in very different posterior estimates based on the same data.
Oh, yeah.
It's been very fascinating. And I think we're going to learn a lot, hopefully, as a society about how to do this better in the future.
Yeah. Definitely. Yeah, these are fascinating topics, and that makes me want to do a whole episode about this epistemological side of things. But that will be for another time. For now, we've already talked a bit about that, but then that's a perfect segue because I wanted to ask you how Bayesian is the world that you work in. How often do you use Bayesian stats?
I think that the answer to that question has become more nuanced over time. There were times in my career when I would have thought of myself as a pretty ideologically Bayesian person. I think that there's a lot wrapped up in that identity, right? There's sort of like the tools and the methods and the philosophy and the community of people that you work with. It's all sort of bundled together. And I think that a lot of my last few years of my career has been kind of unbundling Bayesianism into some of the core aspects of it. And so do I fit models with HMC all the time anymore? Or do I use Stan regularly? The answer is no, because it's actually quite challenging to fit some of the models that we're fitting at Lyft at that kind of scale with those kinds of methodologies. But a lot of the core ideas get borrowed. And I think that you don't throw the baby out with the bathwater. You keep the stuff that's good about Bayesianism when you're working in places where you're, constrained from writing down a generative. Even if you can't write down a generative model, you can borrow some of the good ideas of Bayesianism. So one of the key ones is just pooling or borrowing information across related contexts. And I think that that's just a relatively generic idea, and you can implement it without Bayesian methods. So for instance, at Lyft, we operate in a number of different regions, and a very naive way to estimate a model of, say, like price elasticities or something like that would be to have like one model per region.
Yeah.
Pooling information across regions can be done with a hierarchical model. I'm sure anybody who's into Bayesian methodology would instantly have lots of ideas about how to implement that. But the implementation doesn't really matter that much at the end of the day. Like, we can add features or some kind of dimensionality reduction to regions into a standard machine learning model and get the same benefits of pooling information across regions. Similarly, for pooling across time, there's lots of ways to do that don't involve like the specific implementation of a generative model. And same thing with uncertainty. So like, thinking about estimating a distribution instead of a point estimate is a very Bayesian idea. I think that you can do that with lots of other methods besides Monte Carlo methods. So a lot of my work in the last couple of years has been use Bayesian ideas, but don't use the specific Bayesian methods because they're not really adequate or very convenient to use. I do think all the time about pooling information across problems. And I think that in a world that's changing very quickly, in a world where we have data sparsity, Lyft has tons of like geospatial data where there's just a ton of sparsity in time and space. And so we end up having to implement solutions that borrow a lot of these ideas. But I still love the Stan project. I still love Pymc. I like all these technologies, but they're not like what I'm using day to day anymore.
Yeah, that's interesting. And I guess we'll talk a bit more about what you are doing and using day to day actually at Lyft now. But first, let's focus on more general discussion, because a question I like to ask my guests is if they remember how they first got introduced to Bayesian methods. So do you remember, and what attracted you at the time?
This is a great question. There was an exact moment, I think, when I had to learn it. I had learned a little bit at NYU. The political science department at NYU has a good Bayesian statistics course. So I had sort of like already learned some of the core ideas, but I wasn't implementing them because most of my training was in econometrics. And econometricians are sort of like notorious frequentists, just like, shoehorning everything into some sort of linear model as much as possible and figuring out how to cluster the standard errors. Maybe you might use some sort of link function or something like that if you encounter some nonlinearity. But there's a kind of a playbook for econometrics. It's very cookie cutter. You have to kind of like play by the rules. I worked on a paper in 2012. We submitted to Science, and one of the reviewers said that your standard errors are wrong on this estimate because you're resampling the same users in the experiment multiple times. And so like you're underestimating your uncertainty. So I was aware of dependence in observations, and this was sort of like, this could look a little bit like a panel data problem. And I was, okay, we could use a panel data method for this, but it was an unbalanced panel. So some of the users appear in the data set much more often than others. And so I didn't really know what to do with that because my econometric training didn't have like a notion of how to estimate a model that was flexible enough to deal with that kind of situation. I found out I could fit a model like this in Elmer in R. So there's sort of like a package that could do this. But then we had sort of a nonlinear outcome in the model, which is like there were three possible outcomes. It was trinomial.
Yeah.
Now I was kind of like firmly out of the standard econometrics literature, like what it can accommodate. And so I was working with a couple of great statisticians at the time. Dean Eccles was working at Facebook. He was a great mentor to me and was sort of like trying to nudge me toward thinking about this more as like a Bayesian model. And then conveniently, the Stan project was just starting to get off the ground at that time. So I decided to implement that procedure in Stan. So we kind of like wrote down a more flexible generative model of that procedure. And that's sort of like the estimates that ended up in the paper were this like hierarchical Bayesian model with basically some kind of random effect structure. And it was really revelatory to me to think, oh, wow, I don't have to just like go look up the appropriate procedure for the setup that I have. I can actually just think deeply about what kind of model that I actually want and then kind of like treat the estimation of that model as an abstraction. So if you look it up, you can look up in the Stan discussion boards. I'm probably one of the first questions they ever got about fitting a model in Stan. And it was like a pretty simple setup and it was taking a long time. And I got some good advice from Matt Hoffman about how to do it. And that sort of was a big breakthrough for me and a path toward like starting to use those models more regularly.
That's a great story. Yeah, exactly this kind of stuff that Bayesian stat allows you to do. It's exactly that, like the generative approach to modeling. Instead of looking up the exact recipe of the procedure that you have to apply in these cases, or just think about how your data are generated, think about the most important phenomena that explain or that make your data generated. Then once you have that, write it down in Stan, in Pymc, in TensorFlow probability, whatever you want, plug in the data and report the posterior, then you'll see what you can say from this. To me, it feels like super liberating, and it feels like also a superpower, because then you're like, man, that's awesome. Actually, I can design a custom model on any problem I'm working on now. I don't have to memorize all these pre-cooked procedure. I can make the recipes myself. It feels really liberating.
Yeah. It's a lot more fun too, because instead of having to kind of look up in the rule book what you're allowed to do, your job is to design a model. I think of models as like containers that hold data. So you're chiseling out an empty space for your data to kind of be poured in to a mold. And that's fun to think about. And then I think as you get better at it, you can start to think about modeling more and more flexible things and making weaker and weaker assumptions. There's a real sort of like art to it that I really enjoy. And one of the really compelling things about Bayesian models to me that I didn't really hit on it as an idea until much later in practice was how the models often have a nesting structure. Some models are sort of like you can keep relaxing some of the restrictions that you made. And so it kind of creates this like continuum of models, from like the models that make the most assumptions to models that make the fewer assumptions. And it gives you a design space that you didn't have in the econometrics world. The design space is very kind of discrete. You either add these fixed effects or you don't. And Bayesian models are sort of like gradual weakening of priors. And so it creates this continuum. And I think that's been a very powerful idea to start to think about the bias variance trade-off more explicitly in modeling, and sort of like what role your assumptions are playing in driving your inferences. And making that connection was a really big intellectual leap for me.
Yeah, that's super interesting and really good points here indeed. And that echoes also something that's actually also part of the Bayesian workflow, which is called continuous expansion of the models. The idea is, instead of taking particular cases, a model that does something very particular, if you're uncertain about that, if you have uncertainty about that, like for instance, you're working on a completely pooled model and you're unsure actually about whether your phenomenon of interest is really generating data that are completely pooled. So then if you are unsure about that, then Bayesian theory says that you should integrate over these uncertainties. So then continuously expanding your model would be, well, then build a model whose extreme cases or whose particular case is the complete pool model. And then you get like your hierarchical model, because then hierarchical model, on one side, the particular case is the completely pooled model. And then on the other side, the particular case is the completely unpooled model. And by doing that, you're integrating over your uncertainty over what kind of model you have to use.
Yes. Yeah, it's a really beautiful idea. And I think there's lots of great examples that I think help illustrate the point, like the baseball player batting average example that's kind of canonical.
Yeah.
Like little kind of like studies like that are special cases of just like this more general idea of this continuum of models that exist. And one of the things that I've been thinking a lot about lately is like the way we coach people right now is to start with the simpler version of the model and gradually layer on complexity. And then some of the things that we've been working on at Lyft recently are more like start with the fully general version of the model, like the most generic possible container that can hold your data, and then start to layer assumptions onto it and see how they change the inferences. And do you start with like making minimal possible assumptions or the maximal possible assumptions, and whether you relax them or add them, I think has been like also a super interesting divide in how people think about doing statistics.
Yeah. An advice that often appears on this podcast is start small and then build up your models, because otherwise, if you start with the most complicated model, it will fail at the beginning and you won't understand why. So start by the simple model.
Yes. There's good reasons to do both, but I think it certainly depends on what you're doing.
And actually, when you do that, I'm a bit curious about your programming journey. Because usually in economics and econometrics, like stata is really king. I think your favorite technical stack is like R and Stan when you're doing Bayesian inference, but correct me if I'm wrong. And so, just tell us quickly about your programming journey.
I was very fortunate that I was super excited about programming from a really young age. And in my undergrad course at Penn, there was this course called OPM 101, which is our operations and information management course. It's like the introductory course. They taught Python to us, It wasn't for working with data. It was sort of just like a generic programming language module. And that was in 2003. So I learned Python quite a long time ago. I was actually really mad we were learning Python because I was like, what is this new language? And like, why are we learning Python instead of something that I've heard of before? Turned out to be a good bet. And I was a web developer. My job after the Federal Reserve Board, but before graduate school, I worked as a software developer for a company that did basically like a CRM system for a couple of years. So I got a lot of exposure to software engineering before graduate school. So I came into graduate school sort of like knowing that I liked coding, I could do it, and that I could build reliable software. I think that's become like a real tenet of me as a researcher, is that I don't think that good research can be decoupled from software engineering. I think that you need to think about reliability the same way that a software engineer does. The questions that you're answering and how well you answer them relies on sort of the quality of the code that you write. So I think that they're very intimately tied together. I like using R a little bit more these days because I think that there's a little bit more of a cohesive set of design principles in the tidyverse and some of the R packages that have been developed in the last few years. Almost like kind of like Apple versus Android is one way I might kind of characterize it. It's sort of like there's an aesthetic for R packages that's sort of shared across a number of them, and they all work together in a pretty cohesive way. And I think that Python, given that it's used for many more purposes than R besides data, sort of ends up having a little bit of a more fractured ecosystem. And it's been harder to align the Python community on like having like one best way to do it, despite that being in sort of the zen of Python. So I still use Python every day. I'm a big PyTorch fan, and we've been using PyTorch a lot within my team to develop the software. And I sort of have some hesitancy about using R to develop sort of packages that we run in production. And I know that's a little bit of superstition. I think that people run R in production all the time and get great results. But I sort of, at Lyft and at Facebook, writing things in Python is the way that people tend to ship things that actually run reliably. And so that's what we've been focused on. I will say that making Python work within the data science ecosystem has gotten a lot better in the last few years. And packages like Altair for plotting I really like some of the method chaining stuff that Pandas has been adding. Pymc is a really fantastic package, and I really love the work that's being done on that. And I think that one of the best tricks that I've learned recently is the black package. Being able to have something like tidy up your Python code, I think, is like an amazing revelation. It's like not having to spend your time thinking about code formatting, which is sort of like what some of the tidyverse stuff is helping you with, is giving you sort of an obvious way to write code that doesn't require making a lot of design decisions about like indentation and what to name things or things like that. I think that having your code be tidied for you is something that kind of changes the way that you think about problems a little bit. So all these things are to say that learning programming is a journey that you have to keep investing in new technologies and be really flexible. And I think the dogma of like one thing better than the other is sort of like one of my least favorite arguments.
Yeah.
Like I think everything's got strengths and weaknesses, and it's really important to just keep learning like what do people like about things rather than what they hate about them.
Yeah, exactly. First, I have to agree, like black, it's amazing. I love that so much. It makes me focus on really the core stuff of my PRs or issues or stuff like that. Second, I've heard about this Pymc package, something like that. I don't know where it comes from, but yeah, I agree. It looks super nice. And third, and most importantly, I completely agree with you. And that's actually something I often say to people like wanting to start probabilistic programming and like being a bit overwhelmed by the choice of frameworks there are now to do that, which is in itself quite awesome if you think back to the 90s, where I think it was super hard to do that. Now you have so many packages to do probabilistic programming, so it's awesome. So usually what I end up telling is just pick your favorite, it's like R or Python or Julia, just pick the one you're most comfortable with, the one you love the most, and then go on from that, because it would be hard to learn how to do object-oriented programming or how to do a package or how to do a model in a probabilistic programming language. So you have to love what you're working on and working with. Otherwise, you're not gonna keep on going,
That's right. I think that the two bits of advice I always give people are like, find a problem to start with rather than a software package. It's like, you don't want to learn a software package. You want to learn how to solve a problem.
Yeah.
Software package is just a tool for doing that. And then I think, your decision about what packages to use and what languages to use are basically also a decision about what community people you're going to be hanging out with. And they're all great communities. I think that like they're all like, there's great people around every good software package. It's almost like an invariant. If there's a good, useful software package, there's got to be a group of people that really love it, that are helping to support each other. So I think making friends in the social aspect of programming, of finding the people, connecting with them, and trying to understand what you can learn from them and teaching others is a really big part of it. And I think that's sort of like tied to the practice of programming in a very intimate way that we don't talk about enough.
Yeah, definitely. Such good points. And it was exactly my experience. I came for the language, like for Pymc, for instance, when I started Bayesian stats, I started with Pymc. So I came on the discourse because I had questions about models and had to do that with Pymc and so on. And in the end, I stayed for the community, because core devs were super helpful on the discourse. So I got to solve my problems. And then when I saw some issues in the package, I opened some issues on GitHub. Core devs helped me solve them. So I submitted some PRs, etc., etc. And in the end, I integrated the core dev team. And now I'm working full-time on Pymc with the Pymc Labs consultancy, and it's with other core devs of Pymc, and these people have become friends. So it's exactly as you say, you start building small, and then before you know it, you're working full-time on the stuff you love. So with people you consider your friends. So it's really amazing how this open source journey can really change your life and the way you work. And as you say, the community aspect of it is huge. Because otherwise people don't give their free time for people who are jerks on GitHub,
It's true.
That's basic, but that's how it goes.
Let me show you how to be a good Bayesian.
Hey folks, as I told you at the beginning, this episode is brought to you by Teelift, and I'm really proud of it. In a nutshell, Teelift helps organizations effectively manage the open source behind modern applications, including the tools to create customizable catalogs of non-good, proactively maintained open source packages backed by Teelift and its open source maintainer partners. For instance, Pymc3, that I'm sure you all love, is part of the Teelift subscription. So if you are using Pymc3 in your organization, you can seamlessly and efficiently integrate it into your organization's software policies and workflows. Sounds nice, right? So go ahead and check out teelift.com to learn more. And talking about awesome package, let's talk about Prophet now, which is, I think most people know, the package you co-created when you worked at Facebook. So basically, first, can you tell us what it is and why did you create it? And what type of models can people build with it?
It's funny, the segue from community support to Prophet, which is a package that I don't feel like I give enough support to the community for.
So sorry.
I'm having some pangs of guilt right now. No. It's fine. We're behind on an R release right now, so I feel a little bit sad about that. And before I start talking about Prophet, I want to make sure that Ben Leatham, my co-creator, gets a lot of credit. I always like to say that the good parts of Prophet are his and the bad support on GitHub is my fault. So you should blame me when you don't like it and give him the credit when you do like it. So we created Prophet because I started working on a forecasting problem at Facebook pretty early in my career there. And I realized that it was quite challenging to do forecasting in a way that I hadn't experienced before with other statistical problems. It took a long time of reflection to figure out why it was. And at the end of the day, it's because forecasting is an extrapolation problem, not an interpolation problem. And most of the models that we work on are very well capable of interpolating. Interpolating is something very easy to reason about what's going to happen, but extrapolation is very difficult in a very different way. So started working on forecasting, realized that there weren't a lot of good tools. Rob Hyndman's, I've never met him, so I don't know how to pronounce it. His forecast package in R was sort of the current state of the art at the time. And it was a little limited. I think that it reminded me of my econometric training of in order to forecast this new thing, you had to know a new trick. And if you go to his blog, you'll actually see he gives people little recipes or, to figure out if you have two kinds of seasonality and this kind of periodicity or whatever, or missing data. So for every little trick, you end up with needing to kind of modify your forecasting procedure in what seemed to be a heuristic way. So, so thinking like a Bayesian, it's okay, I need to think about what's a class of model that can do this and how generic can I make it? And then what assumptions do I need to make to have it fit the specific data that I have? What we landed on was the idea of curve fitting as a forecasting procedure. And I think a lot of pure time series forecasters actually really appalled by this because it's not a full generative model of the time series data. It's a generative model of a curve that can fit the data. And that's actually quite a different idea. But when you move from having to kind of recursively generate each observation of a time series data to fitting a curve, curves are something that I think we have a lot of good intuition for. And so we had to basically create priors over curves. And so what Prophet is basically a set of good heuristics and priors over curves that tend to fit business time series data fairly well. And business time series data has certain sort of properties that are repeatable, or at least we noticed a lot of repetition in problems at Facebook. And so it was worth sort of figuring out what's a class of model that tends to fit these data sets that we're observing in practice quite well and can be fit very quickly and get to the point where we're kind of like, you can interactively work with the data, with the model. And so the speed thing was very important. So we had to figure out like a procedure for fitting these sort of like generalized additive models that was fast enough that people could iterate on different priors and see which priors corresponded to models that forecasted well. And so it was a natural extension from that to implement it in Stan and think of it as like a Bayesian model of curves where you can have priors over like what kinds of curves that you're expecting. So in a lot of ways, we think of Prophet as having sort of like a control panel where the knobs and levers are priors. And so that gives people some control over the curve that they're fitting. And that control corresponds in a lot of ways to like giving them ability to inject domain knowledge into the forecasting problem in a principled way, rather than just like overriding the data or transforming the data or having to kind of like come up with a heuristic that fits the data. You put your domain knowledge directly into the priors, and then that improves the forecasting model rather than some other way of doing it.
Yeah, I love the way you summarize that. Super Bayesian, like just the summaries, you make it seem like it was inevitable to use Bayesian framework and use Stan to do that, because like it can really be answered really well by the Bayesian framework, what you're saying.
Well, yeah, forecasting is always a really data constrained exercise. It's like you just don't ever observe like infinite samples from your time series process. You have a very short amount of time of observed data to make a forecast. So you lean very hard on your priors when you're forecasting, whether you like it or not. And I think that once you acknowledge that, the Bayesian setup is a very natural one.
Yeah, definitely. And that was going to be a follow-up question, actually. It was going to be, why did you make that a Bayesian package? You know, like, why did you use Stan and so on? But you actually answered. And something I'm curious about, though, is because this package is also used a lot internally at Facebook, right? So I'm wondering, when you put that into production, when you deployed the package, did you have some pushback from people not used to Bayesian methods? And if yes, what was it? How did you diffuse that and so on? You know, like the internal politics of statistics departments in big companies.
I don't think that we had a lot of pushback at all, because some of the success of Prophet is that people had very few options before. So I think if you present somebody with a convenient option where they had very few options, then it's very natural for them. Adoption is quite easy for tools in that space. If they have something that they're doing that they like, it's quite difficult to get people to change. But if they're not really doing something that they think is effective, then it was a pretty easy sell. I think we as developers sometimes question the choice of wrapping Stan. It leads to some installation problems, and it's a lot of dependency to add for a package like this, where sometimes it doesn't feel like it may be totally worth the effort. But the Stan team has been amazing with helping us with that. Anything that we come up with that's sort of a problem that's originating from the Stan side of things, they're very quick to help us with that. So I think once you acknowledge that you're part of an ecosystem of packages and that the other people have a role in helping you and you form good relationships with them, it gets back to that social aspect of programming. That became sort of more of a strength than a weakness. It's like, okay, having the Stan project on board wasn't causing us to have problems. It was actually providing this benefit. Plus we had this like support system to help us solve those problems. And then the actual aspect of it being a Bayesian procedure is very hidden from the user. So we call things priors in the parameters. And if I could do that all over again, I'd probably even remove that. I think that the fact that it's a Bayesian model under the hood is an implementation detail in some ways for users. Really what they care about is that they generate a forecast that's accurate and that they like. And so the actual like act of how that's created is maybe not as important. So I hope that the users that think the Bayesian aspect of it is interesting peek under the hood and look at the Stan code and maybe modify it themselves. And we've seen people do that. And for users who don't really care about that stuff, they treat it as a reasonable forecasting heuristic that is something that they can use and not need to know about how it works.
Yeah, I see what you mean. I would be interested in this ratio, by the way. How many people really go peek behind the curtain and like get involved into more Bayesian thinking and methods because they picked up the Prophet package from the shelf? That would be interesting to know.
So by default, Prophet doesn't even use any of the HMC functionality of Stan. It's just, it's literally using Stan to solve a nonlinear optimization problem. And so just performing map estimates. You can get a posterior distribution if you'd like from Prophet, but that's not the default. And so I think a good proxy for whether people care would be whether they actually use the sampling or just the optimizer.
Yeah, exactly. Yeah. Well, people's tendency to stick to the default, I'd say most of them stick to the default. So of course, you know what I would say? I would say you should change the default. Make the default MCMC estimation, but that's another debate. And yeah, actually, to echo what you were saying about the stand team support and so on, I agree. It seems to be really amazing because I definitely had some problems with the C compiler when installing Prophet, for instance, for using it with Python. But I found answers quite easily on GitHub, especially thanks to Hierarchical, who is one of the PyStan core dev, and he was commenting on a lot of issues about exactly this kind of problem. So definitely, you're not alone out there if you have some installation problems. It's super classic. I mean, to give a bit of a behind the scene flavor to the listeners, Sean and I had a bit of an installation problem before recording the podcast, so it's like everybody has installation problems.
Yeah, I think in a lot of ways, a lot of people's experience with software and whether they like it or think that it's high quality or not is like in that first few minutes of like, does it just run the first time?
Yeah.
And you update your posterior based on that information very quickly to say like, this is a shit package because it took me half a day to install it. So I hope that the benefits make up for the installation friction for people sometimes.
Yeah. Oh, I'm pretty sure. And from my experience, it clearly did. And actually, talking about that, what do you think are our Prophet's main strengths and its main weaknesses?
Probably the strengths are empirically, the model works well. And when we've seen it give reasonable behavior across a wide variety of data sets. And I think that that's the sign of a good model architecture, is that it sort of like it generalizes well despite relatively strong priors. So that means that those are good priors. So I think, a lot of domain knowledge about what a good set of curves that would fit time series data that you're likely to encounter in practice are encoded in the model. And I think we've also sort of developed a little bit of a loose framework for how to think about forecasting that's built into the package. So it's not super prescriptive about how to do it, but I think it provides some loose guidance that is relatively useful for people that are starting from scratch. The weaknesses are, I think installation is definitely one of them. I think people have a lot of problems with that. We tried to build it in a way that was extensible to a number of different problems, but I think that it's worth acknowledging that it's not a one-size-fits-all solution, and that those priors, when your time series isn't sort of generated by similar family of processes to that we've seen before, then it's likely to be a poor model. And we've seen people apply it to things that it's like totally inappropriate for. And I think that they get bad results, and that sort of makes it make sense. And I think if I could be more helpful to those people, it would be through a better model checking procedure. And we're not that prescriptive about model checking like you would be in a good Bayesian workflow right now. And I think if I could do it all over again, I think that the model checking and model validation would be more at the forefront of the package. It's just that model checking and validation for forecasting is actually like a pretty challenging problem on its own.
Yeah.
And computationally intensive. If I could do it all over again, that's where we would start with, is sort of like, how do you want to validate your model? And then work a little bit backward from there. I think we're not as prescriptive about that. And that might lead to people sort of like, thinking that their model's good when it's not. And that's sort of the most dangerous thing that you can do.
Yeah, especially in model checking, model diagnostics and so on, especially for time series, is hard. Like, you have to implement leave future one out. That's tricky, and that's also a very dynamic area of research. So solutions are coming, but they have still not percolated very well into mainstream methods and packages. They are still in academic papers somewhere, but they still need to be implemented at a wide scale. So it's definitely a challenging thing to do.
I hope that you all on the Pymc project can help sort of bridge the gap there, because I think that that's a great role for us software developers to like help understand and make accessible this like state-of-the-art thinking and then implement it in a way that's accessible to people.
Yeah, definitely, exactly. And that's also something that's super stimulating when you're a core developer of an open source package like that, because you get to implement state-of-the-art methods that were in academic papers and then allow people and general users to use them in the problem, which is like super nice and also very interesting for you intellectually. And actually for the diagnostic parts, now it's handled by the RVs package, which is like a Python package. We also have a Julia wrapper. And yeah, this package, for instance, like implements a lot of state-of-the-art diagnostics for models and model comparison algorithm. So definitely keep an eye out on the RV's website, folks. We have a lot of people working on that, implementing the latest methods. A question I wanted to ask you to get back to Prophet is there one main feature that you'd like to add to Prophet if you had the time?
So the most requested one is probably being able to simultaneously forecast multiple time series that are related in some way.
So like hierarchical.
Yeah, well,
series.
They need to share information some way. The question is, like what should be shared between the time series? Should you be sharing the growth rates or the seasonality? Which parameters are worth sharing and which are not? And I think that we just haven't seen a lot of examples of like time series where sharing the information is particularly useful. Certainly a lot of time series have like a low dimensional structure that could probably be exploited. And there's some ideas around how to do that. But that's the thing that I think people request the most. But I'm sort of still a bit dubious that Profit is the right model for pooling information across related time series. I think there's probably better ways to do it. Another one that comes up fairly regularly is adding some sort of like time series process on top of the residuals from Profit. Right now, the errors are assumed to be independent within the model. And I think something like an autoregressive model on top of Profit could be like a useful extension. And probably the one that if I could go back in time and change things, it wouldn't change the model or the fitting procedure at all. But the way that you express a Profit model, I think is like a little bit clunky right now because we packed everything into the parameters for the forecaster class. I really admire packages like ggplot where you sort of create a grammar in order to construct the model. Since it's an additive model, there's sort of like a clear decomposition of components and there's a composability to Profit models that we're not really exploiting in the way that you set them up. And I think if I could do it all over again, we'd probably redesign the interface for creating models to be a little bit more composable rather than something that relies on the user knowing a lot of parameter names and default values. It's just a usability thing, but at the end of the day, like usability is probably 80% of the reason why people are using a package like Profit.
Yeah, I see what you mean. And by the way, about hierarchical time series, I know that recently, like at Pymc this year, which was the first ever, there was a talk by Matthijs Bruns, if I remember correctly. He lives in Amsterdam and he created this Python package called time series, and which is actually based on Profit.
Oh, wow.
And he added a hierarchical time series component on it with Pymc 3. So maybe you guys can talk about that if you want. I'll definitely put time series GitHub repository in the show notes for people to check out and for you also if you want to check it out.
Yeah, that would be great to see. There's also, I should mention that some folks from Facebook just built a package called Neural Profit, which is Profit based on PyTorch, and has a number of features that sort of leverage that support. So I'm excited to see what they did too. I'm always really flattered by the extensions and the ideas that people are building on top of Profit. I never really thought it would become the basis for other people's work. I'm excited to see what other people do. It's sort of one of my favorite things about open sourcing projects in a lot of ways is that somebody kind of like yes ands your project and adds something that you never really would have thought of or something that you thought of but you didn't have time to do. And it's one of the most exciting things about working in a community.
Yeah, definitely. Plus, I mean, like this time series package, I love it because it's like Profit is based on Stan, and then he added the hierarchical component, but did it with Pymc 3, so it's based on Pymc 3. I mean, that it also goes a long way to show what we're saying at the beginning. If you like some language or some framework, just pick this one and work on your project in it. You can do it. Like these tools are quite easily interoperable. It's really a good time to live in, you know.
I do think that's right. It's never been easier or more fun to work with data than it is today, and will be even more fun and easy a year from now. And I think that's one of the most exciting things about the field is that the things that used to be really annoying are getting less annoying, and the things that used to be really hard are getting less hard. And that's just like a huge opportunity for everybody.
Yeah, definitely. We're getting short on time, so I want to ask you now about what you're doing today at Lyft. What are you doing, actually? And how does what we all talked about relate to what you're doing at Lyft?
Yeah, those are great questions. I manage a large team now, and so there's a lot of different projects going on. So it's hard for me to pick one to highlight that I'm more excited about than the others. But we're working on forecasting, but what I would call counterfactual forecasting. So it kind of like marries my two interests in forecasting, but also with causal inference. And the reason we need to do that is that we intervene in our marketplaces in a way that affects the forecast outcomes. And so we need some notion of causality. And one of the common failure modes with forecasts in general for businesses is that the forecast is obsolete the moment that you make it, because then you take steps to change the forecast. And so we've been working trying to reconcile that. And roughly what that looks like are structural models of our marketplace that are capable of doing time series forecasting. And so that's been a big ongoing project for over a year. Very excited. I think some of the work that we're doing there might end up being able to be open sourced at some point. So that's a very exciting area. Another big area is experimentation. One of the hardest problems with a marketplace like Lyft's is knowing when the change that you made to the marketplace is better than the old way that you were doing things. And it sounds deceptively simple, but actually, because every day the marketplace is a little different, the supply conditions are different, the demand conditions are different. that variance really adds up to a lot of decision-making uncertainty about whether what you did was good or you just got like a lucky day. So we're working pretty hard to figure out how to improve the precision of the tests that we run, which basically means better models at the end of the day. It's like we think of it as a residualization problem. How do you explain the variance in your outcome that you don't have control over? And so you can kind of let the variance that's explainable by the things that you did do really speak. And so we have some really exciting work going on there. And the big upshot of that is not just like more certainty about decisions that you make, but it's also about cadence of decision making. The ability to decide if you made a good change within a day or a week instead of 2 weeks or 4 weeks is a night and day difference in how many things that you can try and how many algorithms you can test. And so it's been very exciting to start to think about a world where it doesn't take 2 weeks or 4 weeks to decide if you made a good product change, but it's something that you can do at a much faster rate. So that's been a big area of interest for me for a long time and something that we're working on very actively.
Yeah, that does sound super interesting. And even though the data you're trying to model seems to be very complicated and I guess at a very large scale, the good thing is that you seem to have feedback quite often, at least like something like every day you've got some feedback on how your model fared. So I guess that's how you improve a model.
I just talked to a friend who's an economist, and she asked a very good question, which is like, how do you know that you're not overfitting ever? Because you always have access to the people who are training models can see the data at all times. So you have to trust them. She's kind of like a little skeptical of machine learning methods because she thought that it's hard to do an honest validation of any methodology. But I said in industry, actually, you get a new test data set every week, every day.
Yeah.
So it's actually like quite feasible not to overfit because we get to sort of always have some held out data from the future that we haven't even seen yet. So there's a more honest comparison. So yeah, I think working in industry is a real luxury in a lot of ways because you're always generating new data and you can design the data sets that you want. You can add new logging, you can run experiments. And so there's ways to gather the data that's adequate for your problem rather than relying on whatever you could kind of scrounge up on the internet. It's quite a different way of thinking about problems.
Exactly. And like, for instance, weather forecasts have become so much better. It's like every day you get feedback on your predictions. So it's like really one of the best ways to just come up with a better model. You just every day you get a new data set to test your model. And so that's really awesome compared to like, for instance, electoral forecasting, which is a lot harder because like in France, for instance, presidential elections are only every 5 years. You have to wait that long to test your model.
Yeah, there's certainly like an argument to be made about the evolutionary dynamic of, how often are your models subjected to some evolutionary pressure of being held accountable for their decisions or predictions.
Yeah.
And if it's too slow, you might never get to a good model. And also it kind of changes the way that you think about modeling as a process rather than a thing. Like a model isn't a snapshot. Any reasonable model that you're going to use in reality is going to be something that's going to have to be capable of incorporating new data as time goes on. And I think that sort of like gets back into the engineering and reliability side of things. It's like getting to a model in a Bayesian framework that works well one time is a much easier problem than a model that can kind of fold in new data over time and not do anything degenerate.
Yeah, I completely understand and agree with that. And these are, again, fascinating topics. Unfortunately, we're getting short on time and you've been already very generous with it. So let me ask you one more question before we go on with the last two questions. This is also a topic I'm very passionate about, and I know you are. It's about controlled experiments and causal inference, because these topics I know you're very interested in. And so I'm wondering, what can you tell us about your work on this? And also maybe more generally, what does the future here look like to you, especially in relation to the data science and machine learning world that you know best?
I feel very lucky to have gotten interested in causal inference as early as I did. I think it's inevitable that all of us should be interested in causal inference because models that don't have some sort of causal interpretation are often a little vacuous, like they don't actually answer the questions that you want to answer. So, getting to a world where most people are aspiring to create models that have some sort of causal interpretation, I think is inevitable. Because if you're not going to think about how changing something is going to affect the thing, then you're not thinking about, a realistic situation where you're intervening in the world. So causality is very important. The easiest way to understand causality is to just intervene, to just like literally make changes and see what happens. I think that's the simplicity of causal inference in a lot of ways, is that you're looking for either interventions that you did or interventions that you didn't do but could have done. I think that at a place like Lyft, at a place like Facebook, it's all about designing. I call it design data, but basically causal inference is all about making data that corresponds to these like what if scenarios so that you can answer them with enough common support for the kind of covariates that you have and the decisions that you want to make, and literally just get precision on these counterfactual estimates. In a world where you can't experiment, causal inference is almost too hard to do. And so people who try to do it in those situations, it's really admirable, but I think they often are fighting an uphill battle. And so that becomes sort of like these epistemological debates about like whether what you were trying to estimate was even knowable or not. And I'm growing less interested in those debates because I actually think that it would be better to just like make the data that you need in order to answer the questions. So I'm an experimentalist. I really care a lot about how do we design the data sets that we need? And it comes down to basically like the interesting part of causal inference now is efficient experimentation. How do you use your ability to intervene in a system efficiently, do it in a safe way, and learn what you need to do in order to kind of like hill climb to a better solution? It's a long-winded answer, but everybody's going to care about causality eventually. And in order to do that, they're going to have to care about designing experiments.
Yeah. No, I agree with that also, because if data and models really become more and more accessible to more and more people who don't really and don't necessarily have the background to really interpret, the results of the models and the cautious that's usually associated with it, then it's really important also to make people really understand the difference between just picking up correlations in whatever ways you pick them up and interpreting that as causal results, and just the causality of A leading to B, and that's really something that's super hard to decipher in model results. And it's already hard when you know and you coded the model and you wrote it. So when you just plug a button and don't really know what's behind the hood, then it becomes super important for people to be aware of these almost epistemological arguments and cautions that they should have.
Yeah, interpretation of models is much harder than gathering data and fitting models. So
yeah.
I think that's a really underrated part of modeling. And the causal part of it is all of interpretation. Is how can I read this and how can I use this estimate to make a better decision or to kind of like draw a conclusion? And it's all causality at the end of the day.
Yeah. And that's where you really need a framework, and a method to interpret that. It's not like you can really just wing it and say, oh, yeah, I think this is causal. It's right. It's really where the scientific methods and protocols that we're talking about at the beginning of the show are super important to keep you on track, Yeah.
We've come full circle, yes.
Perfect way to end the show. It's like a show without an end. It's like we're talking about the same thing as at the beginning. Okay, Sean, thanks so much for being on this show.
Sure.
Before you go, though, I'm going to ask you the two questions I ask every guest at the end. It's a tradition. And as I often say, it's more about the distributions of answers than about the particular answer that you are giving. So, first one is, if you had unlimited time and resources, which problem would you try to solve?
I mean, that would have to be climate change, I think. Mm-hmm. It's one of those problems I never even think about because it sounds just too hard to even start. But with unlimited time and resources, that would relax that constraint. And I would say, let's go save the world.
Yeah. That's reassuring. You are in good company with this answer. I mean, a lot of people have answered that on the show. So with you folks, we can have a good team of people working on that. Second question is, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
That's a really good one. I think I might go with Richard Hamming would be a really good one, I think. Stripe Press just published a version of his old book, and it's really a wonderful book. And I didn't really follow his work very closely earlier in my career, but I think he's got this sort of like intersection of engineering and science viewpoint that I would love to just like pick his brain about. Because I think talking to a pure scientist, I wouldn't quite be satisfied. I would want to have a conversation with somebody who both had the scientific mind, but also was really focused on how to build stuff. Because I think that hybrid thinking is like exactly what I'm most interested in.
Can you just give the elevator pitch of the book for listeners who don't know it?
I think that Hamming's ideas basically pertain to like, how do we apply science to solve real problems? And so he's an engineer who does scientific work. And I think that it ends up being sort of like a structured way of thinking about problems. I don't know if there's any like one lesson to take away. I think it's just people who have that kind of breadth of experience and have worked on things for so long.
Yeah.
It's worth just like, hearing all their reflections because there's like a holistic wisdom to it.
Yeah. We should definitely put that book in the show notes of the episode. Well, Sean, thank you. It was really great talking about profits, social science, and causal inference. You sure do a lot of interesting things. As it happens, these are topics I'm also passionate about. So thanks a lot for
all the open source work you're doing. I learned a lot, and I'm sure listeners did too. As usual, I put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Sean, for taking the time and being on this show.
Thank you for having me. It was really fun.
Yeah, you bet. Bye. Take care.
This episode of the Learning Bayesian Statistics podcast was brought to you by Teelift. Teelift helps organizations effectively manage the open source behind modern applications, accelerate development, cut costs, and reduce risk with the Teelift subscription, so you can create even more incredible software, even faster. Learn more at teelift.com. This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher or purchaser, and visit learnbayesstats.com for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman with MC Lars and Megaram. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thanks so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.